Hey, how you doing? My name's Elton and welcome to the show. So this is my new YouTube series where I talk about everything to do with containers. So Docker, Kubernetes, the container ecosystem, patterns and practices, architecture, all that good stuff. Really simple format. I'm going to do 4 episodes a month, more or less. And each month I'll revolve around a particular theme. So we're going to be covering over the next few months. I've got it all kind of planned out. It's going to be interesting things like which orchestrator should I use? How do I do observability in containers? How do I do CI/CD? Where does security fit in? All that good stuff is coming. But we're starting with a theme that's really close to me because it's how I got into containers in the first place, and that's Windows containers. And before you click away and go and watch something else entirely, Windows containers are real and they're a really important technology. So even the Kubernetes website itself says that Windows containers, Windows workloads are one of the most significant things out there in the enterprise. So back when I was consulting, especially the bigger enterprises, like more than 50% of their stuff runs on Windows. So if you're looking at a long and fruitful career in IT, then knowing how to run those older Windows applications in containers and run them in Docker or Kubernetes is probably going to be pretty useful for you. So that's about it. If you've seen me present before, you know the format. It's mostly demos. It's mostly hands-on stuff. All the resources are on GitHub, so you can follow along with me. And this show is no exception. So I'm going to switch over to my code window here. But to do that, I need to pull down my green screen. I need to twiddle with my microphone a little bit. So while I'm doing that, I've got a 20-second advert for you to see. So you don't have to watch me fiddle with my green screen. And I'll see you in just a few seconds over there. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. While I'm fiddling with my green screen, you might want to bookmark this page, eltons.show, which is where you'll find all the details of all the episodes. I go into quite a lot of depth in these shows, so if you want a primer around these technologies, I can recommend my books, Learn Docker in a Month of Lunches, and Learn Kubernetes in a Month of Lunches. And if you just want to see what I'm up to, then you can check out my blog, blog.sixside.com. And now, back to the show. Well, that seemed to work pretty well, so hopefully the advert wasn't too annoying. So yeah, you know about that stuff. I write books, I do Pluralsight courses, I'm working on a Udemy course right now, so if you're interested in this stuff that I do on YouTube, there's plenty more of me out on the internet. So this is for, if you follow that eltons.show link, that's the GitHub pages, which takes you to the GitHub repo where everything is that I'm doing in the series. And today's all about Windows containers. So this is ECS-W1, so ECS is Elton's Container Show. W1 is the first Windows episode, and it's called We Need to Talk About Windows Containers. So there's a few links in here of things that I'll talk about going through the show, but mostly I'm going to dive straight into the demos. Now, the thing to bear in mind with Windows containers is that the workflow is exactly the same. Whether you're using Docker on Windows or Linux, you're going to use the same command lines. The Docker file syntax is the same. The compose syntax is the same. The Docker API is the same. But the Docker containers are the container images are built to run on a particular operating system. So if you're running on a Windows container, then you need to run an image that's built to run on Windows. And you can't run an image that's built to run on Linux. So things get a little bit confusing when you're running Docker desktop because it lets you run Windows and Linux containers. And it makes it super easy, and people get kind of misled into thinking that Docker can run anything on any operating system. So the first demo I'm going to show you is using plain virtual machines instead of Docker desktop to show you that isn't the case, that you have to run the container matching the operating system that you're running Docker on. So what I've got here, let me close down the browser and open up the terminal. I've got a couple of vagrant virtual machines that I've already got set up. All the stuff's in GitHub, so you can follow along with this if you like. So I've got 2 sessions here. This is my Linux session, and I've got a Windows server as well. So I've got an Ubuntu server machine and a Windows Server 2019 machine. They're both headless servers. They don't have any UI. All I've got installed on them is Docker. If you want to see, here's the setup scripts. They're really basic. So with the Linux server, I'm just using the get Docker script, which is really useful for non-production and test environments. You just run that script from the website. For the Windows setup, it's slightly different. You can install Docker with PowerShell, and that's what I'm doing here. So there's a few prerequisites that you need. You need this Windows feature for containers, and then you need to install the provider from the gallery, and then you install Docker. So it's just a few commands to run. You get it installed in Windows as well. Okay, so the first thing I'm going to do, I'm connected to my Linux machine here, and I'm going to run, so I've just run these commands so you don't have to see me do that. I've done the vagrant up to create my machines. I've done the vagrant SSH to connect to those machines. I've got one in each session. And the first thing I'm going to do is I'm going to run Docker version. And what Docker version does, if you haven't really looked at it before, it gives you 2 sets of output. One for the client, which is the Docker command line, and that tells me that I'm running on Linux because I'm inside my Linux virtual machine here. and then one for the server, which is the Docker engine. So the Docker engine is the thing that actually runs your containers. It's got a REST API that you can connect to create containers and list containers and all that sort of stuff. And that's what the Docker command line does. It's just the client of that API. And then my operating system for the Docker engine, that's Linux too. So I'm in my Linux virtual machine. Everything's Linux. Okay, so if I clear this down, I'll use the right command. So the first thing I'm going to do is I'm going to run a really basic container. So these are the container images from other stuff that I've done. So this is one from the Docker book. It's Apache. It's built to run on Linux. So you can see in the container, in the image tag there, the image repository is diamol/Apache, and the tag is Linux AMD64. So I've built this with a tag to indicate what operating system it runs on. You can see that it's downloaded the image and it's running the container. I get the long container ID out there. And if I clear this again and run PS to show me the processes that are running. So this, somewhere in here we go. Is my head in the way? No, you can see that. So I can see these HTTPD binaries. That's the Apache web server. So Linux containers, you know how those things work. The container is just really a wrapper around a bunch of processes. For Apache, it starts that HTTPD process inside the container. And because my container is running on my VM, when I'm connected to the VM, if I look at all the processes, I see those container processes as well. Inside the container, I wouldn't see all the rest of this stuff. I would just see the container process. But on the host machine, I can see all the processes for all my containers. That's what makes Docker so super lightweight. Okay, so that's CLS. So that makes... I usually put an alias in for CLS to become clear because I've used CLS like my entire life. Okay, so now if I browse to the VM address, so somewhere in all this mess here, there's an actual IP address. So I'm using Hyper-V on my Vagrant machine. So I'm going to open Firefox. I'm going to browse to port 8080 on that machine. And that is the default page that you get with Apache, with the Apache web server. So you just get an HTML page saying it works, which then you see that, you know that it works. Okay, so that's all fine. So that's on my Linux virtual machine. If I switch to my Windows virtual machine here, I'll do the same thing again. So I'll do a Docker version, and I'm typing here, which is why I'm making all these mistakes, and I should be doing copy and paste. So completely different output. So I've still got the client list here. So the client is my Docker command line. This is all Windows because I'm inside that Windows VM. The operating system is Windows on Intel. And then the server, that's Docker Engine Enterprise, which is the enterprise cut, but you're allowed to run that inside Windows Server. That's part of your Windows license. So that's a deal that the Docker team cut with Microsoft a long time ago. Windows containers have been around since 2016. They've had production license since 2016, and this is the version that you can install on Windows. And it's running the Windows operating system. So this can only run Windows containers. Okay, so let me show you that. So if I clear this down using CLS, I can run those same commands, but I have to use the Windows variant. So if I take this Windows version, so Docker run, same command, Docker run -d -p, all the arguments are the same, the syntax is the same. All that's different is I'm using the Windows tag of the image. So it's pulling that image down. I deliberately cleared everything down first so you can see everything working in the same way. If you're not familiar with Windows containers or you're not familiar with Linux containers, they both work in effectively the same way. The user experience is the same, all the artifacts are the same. Okay, so it's downloaded the image, it prints out the long container ID, and now this is listening on port 8081, I think. Yes, okay, so let's clear this down. Get the IP address of this machine, which is 172 blah blah blah. So I'm going to browse to that one as well, and that was port 8081, and it works in the same way. So this is an image that I've packaged up as part of the Docker book. So I've got Windows variants and Linux variants. It's just Apache. It's built on a minimal operating system, so it's running Nano Server on the Windows variant, and it works in kind of the same way. But I can't mix them around. They still work in the same way in terms of isolation. So if I run get process on my Windows VM, then somewhere down here it's all abbreviated, which makes it kind of hard. But if I browse all the way up here, you can just about see I've got my HTTPD binaries. So same thing, the process inside the container that's wrapped around, that becomes the container environment, but I can see all those processes running directly on the host. So same lightweight mechanism, same kind of principles of how Docker works, how the containers work. Under the covers is totally different because on Linux containers, you've got C groups and namespaces to provide the isolation. You don't have that in Windows because it's not part of the Windows operating system, but you have got equivalent features which let you get the same kind of user experience. Okay, now, if I'm on the Windows machine here, which I am, and clear this down, if I try to run the Linux variant, so it will say I can't find that image, it will try and pull it, and then immediately it says operating system Linux cannot be used on this platform. So when you run Docker version and you look at the operating system for the engine, that's telling you what operating system that Docker engine is running on, and that has to be a match for the images that you want to run because the process is run directly on the operating system. So I couldn't pull down a Linux image and try to run a Linux binary because my Windows operating system can't do that. And rather than pull the image, which could be hundreds of megabytes or gigabytes, Docker looks at that first of all. So as part of the image metadata that's on the registry, the Docker engine can read the metadata. It can see that that image is built for Linux. It doesn't have to be part of the image tag. It's all part of the metadata. And it will say, I'm not going to run that because I know I can't run it. And if I try to be clever and say, well, I'm going to try not to run the container, I'm just going to pull the image, I would get the same output because when Docker pulls an image, it doesn't just download the zip files, it downloads them, it extracts them, it gets them all ready to run a container. And it can only do that if the operating system matches. Okay, so that's the first thing. If you think you can just run Windows containers and on your Windows machine, you can run Windows and Linux containers, then you can't. You probably think that because Docker Desktop lets you do that and it makes it super easy. So I'm going to switch away from my VMs now and go back to my basic machine, which is my Windows 10 machine. I've got Docker Desktop installed. And Docker Desktop has this nice little whale icon down here. My head is in the way, so I'm gonna lean over here. If I right click, then I get the option to switch to Linux or Windows containers. So I'm in Windows container mode at the moment. Now, that makes it look as if I'm just kind of switching a tiny thing, but what's actually happening is that Docker Desktop is managing a Linux operating system for me running on Windows. So just like with Vagrant, I spun up my own Linux virtual machine. Well, Docker manages a Linux operating system for me. It's either going to be Hyper-V if I'm using an older version of Windows, or it'll be the Windows subsystem for Linux, which is a much more lightweight way of doing it if I'm using the latest version of Windows 10. But Docker Desktop makes that super easy, so it kind of obscures the fact that your Windows images have to be running on your Windows Docker engine, and your Linux containers have to be running on the Linux Docker engine. But you can run both on desktop as long as you understand what that actually means. So I'm running in Windows container mode at the moment. Let me just double check that, but I'll run my Docker version command, which I run several times a day because I'm never sure what I'm connected to. And here's my server. It's running Windows. So I'm running Docker Desktop, but it's Windows container mode. Okay, so let's clear this down. And I need to remember next time not to put my whale icon somewhere else. Okay, so I'm going to run a Windows container. So this is a tweet application. It's a really basic application that I've been running for some other stuff I've been working on. I've published that to port 8080. And if I'm going to go and switch to Linux container mode here, so I'll dive over here so you can, I'll go this way. So I'm switching to Linux containers. On the other screen, it says Docker Desktop is switching. What that's doing is it's spinning up my Linux operating system, either my WSL distribution or my Hyper-V virtual machine. It manages all that for me. And it repoints my Docker Desktop command line to point to the correct Docker engine. So both engines are running, but only one of them can be connected to by the command line. So now, if I do a Docker, if I'm on the right screen, if I do a Docker version, I will now see that I've switched to Linux container mode. So I'm running against my Linux operating system. Clear this down and go back to where I was before. If I do a Docker PS, then I'm running a container that I started when I tested all this earlier. So that's the Linux version, which is what I was going to do here. So let me remove that. And I'll clear this down. So I'm not running I can't see the Windows container that I'm running, but it is still up and running. So I published that to port 8080. So if I browse to port 8080, here's my Windows container. So my Docker engine is still running. It's still running my Windows containers. The ports are still being managed. When traffic comes into my host, it's still being owned by Docker and sent into the correct container, but I'm not managing that Docker engine. I've switched over to my Linux Docker engine. So now if I run my tweet app, the Linux version, and it's the same again, same kind of commands. I'm publishing to a different port because the previous port I've already used. I get the container ID back. If I browse to 8081, then I see I've got the Linux version of the app and the Windows version of the app is still up and running. So Docker can run both those containers simultaneously. They can't connect to each other over a Docker network because they're on separate Docker engines. But by publishing the ports, I can get those containers to talk to each other if that's something that I need to do. Okay, so now if I look at Docker PS, and what I'll see is I've got my tweet application, but I don't have my Windows one. And if I switch to Windows container mode here and dive over this way, switching to Windows containers. Again, I get the pop-up on the other window, and all that's doing is it's leaving the Linux operating system still running with my Docker engine and my containers. It switched me back to my Windows container engine. So now when I do a Docker PS, I see my tweet app, which is the Windows version that's published on 8080. I don't see the Linux version, but again, just to hammer the point home, the containers are still running. So my Linux containers are still running. All that's happened is my Docker command line is now pointing to a different engine. Okay, so now you've got an idea of how all this stuff works, how it's different on Linux and Windows. What are these things for? Well, your Windows workloads can run on kind of basically any Windows application that's been around for the last kind of 15 odd years. There are two Windows base images. There's Windows Server Core, which is pretty much Windows Server 2019, minus the UI and a few other features that you're probably never going to run in a container. And that's backwards compatible since to kind of whenever. So you can take your .NET 2 applications that you wrote in 2014 and you can in 2004, sorry, and you can run those in a Windows container based on Windows Server. And there's also Nano Server, which is a cut down version of Windows. It doesn't have the full Windows Server API, so you can't run 32-bit apps in Nano Server, you can't run .NET apps in Nano Server, but you can run cross-platform things like .NET Core and Go applications in Java and all those sorts of things. So you've got Windows Server Core for backwards compatibility, and you've got Nano Server for more modern, lightweight applications. So if I go and look at the applications that I've just been running, this tweet application, so it's up on Docker Hub, it's just a public image. I've got a couple of variations here. So let me zoom in just a little. So I've got my my Windows variant here that I uploaded earlier. That's my Windows operating system. Again, that's part of the image metadata. So that's how Docker Hub knows about the container image. It knows what operating system it's built for. I can see the compressed size is 1.8 gigabytes. So this is a Windows Server Core image. It's a really simple web application, but it's built as a static HTML website on top of IIS, which is the Windows web server. Now, in order to package that up, I'm basing it on a Docker image that Microsoft own that already has Windows Server Core and IIS already installed and configured. And all I do in my Docker file is copy over the HTML that I want and set up the application in my Docker file in the usual way. And because of that, I've got this huge image, but it's the base image that's big. It's the Windows Server image that's big. And remember, when you're dealing with images, they're physically stored as lots of small layers, and those layers get shared between images. So if I've got 10 images that are based on Windows Server Core, I don't have 10 times 2 gigabytes of compressed image. I have 1 times 2 gigabyte of compressed image, and then 9 images that use that all reference that image and just add their own application binaries on top. So their images are big, but that's only really an issue when you're pulling down a new version of the base image because it always gets shared. And compare that to the Linux version that I ran. So here's my Linux version. Again, the registry knows what operating system it is. The compressed size there is 9 megabytes, so that's significantly smaller. Again, the goal there when I'm building my Docker image is I use a base image that's the smallest thing that would give me everything I need. If I needed to run a Windows web application and I had to run it on IIS, then the smallest image that gives me that is the one that Microsoft provide with IIS installed. If I'm running in Linux and all I've got is a static HTML website, then I can run it on Nginx based on Alpine, which is this tiny 9 megabyte image. So that's a big difference you've got there, and the cost that you've got in the base image size. That's the price you pay for having all that backwards compatibility. You can literally take your old binaries from a virtual machine that's running Windows Server 2003. I know because I've done this for a DockerCon demo. You can take those binaries from the VM, copy them out, put them into a Docker file, do a Docker image build, and run that application in Windows Server 2019, in the cloud, in Kubernetes, in containers without changing your application at all, even if you don't have the code available. Okay, so that was a bit of a lengthy digression. I was just meant to show you the sizes, but that's the thing there. Okay, so let's have a look at some of these things that you can run in Windows containers. So I'm going to run SQL Server, which is a pretty standard Windows application that you run. It's the Microsoft database. It's been around for a long time. It's really fast and powerful and easy to use. There's a Linux variant now, so you can run it in containers on Linux. But if I'm a kind of Windows developer, I might want to spin up a SQL Server really quickly, and that's all I need to do. So the only things that are different there, maybe that you're not used to, is this is the standard port for SQL Server 1433. So I'm publishing that port so I can work with it on a local client as if it was a remote database. It just happens to be a container. And then I've got this highly secure way of specifying the admin password. Now, you know, if you've seen my Learn Docker in a Month of Lunches series, you know that one of the goals of packaging your image is to have one image that's generic, and you can run that same image in any environment and then apply the application configuration at runtime, either with environment variables or file mounts or secrets or whatever your platform supports. This obviously is not secure, and you would obviously not do this in any kind of production or even a test environment, but it's a super quick way to get up and running. So I'm setting in my password there. And then I'm going to run another SQL Server container. So this will be a completely separate instance of SQL Server. It's based on the same base image, which gives me a clean install of SQL Server. And this is published into a different port, and I've got a different container name, just so I can run it alongside each other. So I've got effectively two completely separate SQL Server databases running in containers that started in just a few seconds. If I look at the list of containers, then I'll see I've got my two SQL Server containers, and then I've got my tweet application that I started a few minutes ago. So that all kind of works as expected. I can connect to those SQL Server instances. I use something called SQL Electron, which you can get from GitHub. Really nice, lightweight SQL connection tool. Inside here, I've got some things set up already for connecting to my local host on port 1433. So that's going to connect to the first SQL Server container. So if I connect to that, I'm just going to run a really quick create database command just to show you that these things are completely isolated, and I could run different containers with different database servers for different applications on the same machine. So I'm going to do a create database. I'm going to call it DB1. And that's all. So that will connect that. And then I can leave that connection. I'm going to connect to the other one, which is on port 1434. I'll do the same kind of thing. I'll do a create database. I'll call it something different. I'll call it DB2. And execute that. And then if I leave this one, go back to the first one, it will have refreshed. So I can see here, there's my DB1 database. In addition to, if you're familiar with SQL Server, I've got the master database, the model, and temp DB, and all those things. I don't see DB2 because this is a completely separate SQL Server, completely separate container with its own file system, its own data. If I go back to my second database container, then there's my DB2. Which has that separate set of tables, completely separate data. Now, if I was to go back to my code here, clear this down, I can connect to that container. So just like I would with Linux, if you're familiar with Docker on Linux, I can execute with Docker exec or Docker container exec to run a command inside an existing container. The IT flag makes it an interactive connection. So I'm running PowerShell inside my first SQL container, and I'm connected to it interactively. So now I'm inside the container, kind of like remote desktoping into a Windows Server machine. I'm going to switch to the directory where SQL Server keeps its data. And then I'm going to list out those data files. And then what I see here, my head in the way, no, my head's okay. I can see the DB1 data file and log file. So it's inside the container file system as part of that setup that you get with that SQL Server image, which is based on something that Microsoft publish. It stores the data inside the container file system. But of course, you can use volumes to separate the data from the container lifecycle. And again, that's something that I cover in my Month of Lunches series, which you can find on a playlist on my YouTube channel. Okay, so that's the last thing I'm going to show you. So just a nice, simple way to run a really typical Windows workload. You don't need to do anything clever with that. That's a generic SQL Server image. So you can use the image that I've published up on there. It's part of a course that I'm working on for Udemy, which will be out soon-ish. And the last thing I'm going to show you is Docker Compose. So Docker Compose, again, works in the same way on Windows as it does in Linux. I've got two of these open now, so let's close one. The same Docker Compose syntax, the same way of specifying your application model inside this compose syntax. So what I've got here is I've got two services. I've got a database service, which is Postgres, so completely separate database server. I've still got my SQL Server running, but that's fine. Postgres is using a completely different port. And then I've got a web application, which happens to be a .NET Core application that makes use of that Postgres database. So if you're familiar with this, it's the to-do list application. I'm sorry, I know they're really boring, but they're really easy to demonstrate. So we'll see how this looks. And again, I've got some different ways of setting up the configuration here. So I'm using an environment variable for non-sensitive data to tell the web application that it should use Postgres for its database. But I've also got a secret provided from a local file, which Compose can do to load up the Postgres connection string. So that includes like the username and the password for the application to connect to the Postgres server, which is actually a Postgres container. Okay, so let's open this up a little bit more. And let's exit out of my SQL Server container. Clear this down and see where I am. I'm at the root here, so that's fine. So I'm going to go into the episode directory for this episode, and I'm going to do docker compose up -d. So same commands, same syntax, same way you're doing everything. I get a little warning about the file path, but it will still all work, so that's all fine. Now if I browse to my local host, I'll get my to-do application. It takes a little while to start up because when this application starts, it connects to the database and it deploys the schema, and it sets everything up the first time that it runs. So I get this little cold start issue, which is great if you're watching a demo and you're hoping that it's all going to work the way it did when I ran it before you were watching. So I'm sure this will just skip through in just a second. And if it doesn't, then I'm going to skip back to my demos. Oh, here we are. Excellent. Okay, so here's the to-do application. Yeah, I know it's got a diagnostics page, so I can prove that it's running .NET Core, and it knows it's running on Windows, and it knows it's running on Intel. So I get that from the application. That's what the application sees. It sees the environment that Docker created for it, and this happens to be a Windows container, so it sees Windows under the hood. I can go into my to-do list, and I can add a new thing here. So I'm going to plan my plan Elton's.show series 1, so I can submit that. That gets stored in Postgres. And again, because that's just a container, it happens to be running a database, it happens to be publishing a port, I can go back to my SQL Electron, my SQL client, close my SQL Server connection, and somewhere in here, I've got my to-do database. So this is the connection string set up to connect to Postgres, which is running inside my new Windows container. If I connect to that, and look at the to-do database, it should connect up to my container. I should see here as a public view. I can go and look at that table, and there's the data that I've just added. You can't zoom in on this little SQL app, so sorry, you have to deal with the small font. But that's the thing that I've just added. So it all works in the same kind of way. So here's the thing to kind of take away from this session is that Windows containers, they have to be running on Windows. You can't run a Windows image on a Linux Docker server, and you can't run a Linux image on a Windows Docker server because the processes, remember that container process, it's running directly on the server. That's what makes Docker so lightweight, and that's why you have to have a match between the container and the operating system, the host that you're running it on. Now, there are several nuances around that, so there are going to be some arguments saying that you can run Linux containers on Windows, and I'm going to deal with that later on in the series. So during this month, we'll have another episode that digs a little bit deeper into that statement and kind of unpicks it, because there are some variants that do let you run Linux containers on Windows, even when you're running the Windows Docker engine, but they're not fully fledged. And certainly in production, if you want to run mixed workloads, so I've got some Linux and some Windows, I'm going to spin up a cluster, a Docker Swarm cluster or a Kubernetes cluster. I'm going to have a mixture of machines. I'm going to have some Windows Server machines and some Linux machines. And then I will run the correct workload on each server. So although there are these other alternatives for running Linux containers kind of directly on Windows, you're probably not going to do those in production. So it's probably better to get it into your workflow that we're going to match the container image to the operating system, and we're not going to try and use any kind of virtualization further down the stack. Okay, so what have we got here? So a couple of comments here. So yeah, any questions you've got to ask me, just kick in, and we can see them in the YouTube chat. So someone says, I forgot to mention my Kubernetes in the month of lunches. Yeah, that's another book that I'm working on. Actually, if you're interested in that book, let me go and open that up so that I can do some proper advertisements here. So if I go to my Docker in a month of lunches website, inside here, I've got a link to my Kubernetes book. That's what Manning call an early access program. So it's a work in progress, but all the chapters are now available. I know 21 of 22 are available. I'm not sure why that is, because I've published them all now. So you can read all of those chapters. Actually, you don't need to buy the book. If you go onto the Manning web, you should buy the book, but if you don't have to, go onto the Manning website, you can read something like 5 minutes a day for free. So if you've read the Docker book, the Kubernetes book is a lot bigger. So there's a lot more detail in there, because I didn't really want to cut detail out just to make the chapters fit in within an hour's lunchtime. So some of the chapters are a bit bigger, but there's an awful lot of detail in there. So that's something to check out. Thank you for pointing that out. Watching. So, hey, Nino, how you doing? Yeah, this is WSL2. Yeah, absolutely. So if you're not familiar with how all this stuff works, Docker Desktop can either use Hyper-V, so that's the original virtualization built into Windows 10. You have to have Windows 10 Pro to have Hyper-V. But now the new virtualization, which is actually run the Linux operating system on top of your Windows 10 machine, that's WSL. WSL2 is the new version. Windows subsystem for Linux. You don't need Hyper-V installed for that. So now you can run Docker Desktop with Linux and Windows containers on Windows Home, Windows 10 Home. So that obviously opens it up to a lot bigger audience. So Paul says, do I have a link for installing Docker on a Windows server? So you will get that from Docker Hub. So you go to Docker Hub, somewhere down here in the installation instructions. Well, they've updated the terms of service. Go to Explore, look at Docker itself, and you will find Docker Server. If you look at Windows, look at that. We should tell the team that they're no longer listing Windows Server in there. Oh, actually, that's gone. So the way you do it is with that script that I showed you. I don't know where the docs have gone. We need to find out what's happened there. Possibly it's to do with the Mirantis kind of and Docker split. So if you look at the Vagrant setup in here for the PowerShell, close this terminal. This is how you do it. If you search, actually it's on MSDN. There's an MSDN page that tells you how to do this. This is the main thing. There's a Docker provider for which has all the versions of Docker available, and then you just do that install package Docker, and you can do an install package update to do an update. That's how you officially install it on Windows Server. So you don't run Docker Desktop on Windows Server. That's a client thing, so you're going to run that on Windows 10. For the server, you'll use the PowerShell install. Yes, and so yeah, sorry, that's Windows. And then for Linux, then you are going to find all that stuff on Docker Hub. So the install instructions depend on the distro you're using, depend on the version of Linux that you've got. So the Ubuntu version here will tell you exactly kind of how you need to set all that stuff up. Here we go. So those are the links. It's all on the docs that tell you basically to do what happens in that get Docker script, but you don't necessarily want to run that in a machine that you don't necessarily trust that script. It might have been hijacked. So this kind of sets it all up for you in a neater way without having to use that script. Okay, so Aaron says, will I be covering Kubernetes in the month of lunches like I have with Docker? Yeah, and he says the Docker book is completely opened his eyes to the possibilities. So yes, I will be doing that Kubernetes book. If this is the first video you've seen of mine, you've got no idea what people are talking about. I wrote this book called Learn Docker in a Month of Lunches, and there's a chapter. You're meant to read a chapter each day, and I did a broadcast on YouTube for each chapter. So actually, it was last month, September 2020. Each working day, I did a chapter, and I went through all that, and it took about an hour each time. The sequel to this book is the Kubernetes book. It's not out yet, but when it comes out, I will do a similar live stream. So the Elton's Container Show, that's going to run in between any kind of other events like this. So the Kubernetes book, even though I've written it all, there's a whole bunch of production stuff that still needs to happen. There's proofing and proofreading and more technical reviews and all that sort of stuff. So it's probably not going to land until, what does it say here now? Spring 21. So I'm thinking February or March. When it lands on Manning and when it lands on Amazon, that's when I'll do the YouTube stream. So, because it's going to hopefully drive people to go and look at the book. And yeah, I will be doing that, and that's going to happen next year. So in between, stay tuned for this Elton's Container Show, because this is going to fill in some blanks, hopefully. Okay, cool. I can't pass the link of doc.microsoft.com. Yes, yeah. So docs.microsoft.com has the how-to to install on Windows Server. So thank you for that, Nuno. Okay, cool. Okay, well, thanks very much. So this is about it. So this is meant to be a really informal kind of thing. So I'm just going to run through these sessions. They're much shorter than the month of lunches because they're meant to be kind of short and sharp. Next time, what I'm going to be looking at is, where's my preview gone? Continuing the Windows container theme, next time we're going to be looking at building and running Windows apps in containers. So we're going to look more closely at the base images that you can use for Windows applications and how you can do things like take an existing Windows installer, an MSI, run that inside a Docker file to package up your application without the source code. And then the other side of that, using a multi-stage Docker build to package up and then run an old .NET Framework application in a Windows container. So we're going to be doing that next week, so stay tuned. I hope you found this useful. If there's other topics that you want to see, just feel free to ping me on GitHub or on the YouTube channel or on Twitter, whatever works for you. I've got, if you look at the GitHub repo, I've got the ideas planned out for the next few months of what I'll be covering here. Anything you'd like to see, please let me know. So I hope you found that useful. My name's Elton. This was Elton's Container Show, and I will hopefully see you again next week. Okay, thanks.